Hello guys, welcome into this video. In today's question we are going to do question 2 of November 2021 maths paper 1. Okay, here we are going to first do question 2.1. Let us jump to another slide. Here is question 2.1. The question here is saying that calculate the value of x. Okay, we know that the ratio of any two consecutive terms in your geometric sequence is always equal. That means T3 divided by T2 is equal to T2 divided by T1, or T4 divided by T3 is equal to T3 divided by T2. Okay, so here we have T1, T2 and T3. Okay, our T3 divided by T2 is equal to let's say T3 divided by T2 is equal to T2 divided by T1. Therefore our T3 is equal to 81 divided by T2, which is 90, is equal to T2, which is 90, divided by T1, which is x. Okay, therefore here we know that 81 divided by 90 is equal to 9 over 10 is equal to 90 over x. Okay, then the next step that we are going to do is to say 9 multiplied by x. We are doing a cross multiplication. We say 90 multiplied by x is equal to 10 multiplied by 9. Therefore 9x is equal to 10 times 90 is equal to give us 900. Okay, therefore x is equal to, we're going to divide by 9 on both sides of the equation so that we get x. Therefore x is equal to 100. We are done with question 1, guys. So now let us, this is our x for that we're looking for, which means T1. Our x is equal to T1. Let us jump to question 2.2, guys. Here we are given question 2.2. Question 2.2 is saying that show that the sum of the first n term is Sn is equal to 1000 into 1 minus 0.9 to the power n. Okay, the question here is saying that show that Sn here is equal to 1000 into 1 minus 0.9 to the power n. We must prove this. Okay, so here we know that when we are calculating the sum of a geometric sequence, of a geometric series, we have a formula which is Sn is equal to A into 1 minus r to the power n divided by 1 minus r. Okay, this is the formula that we use when our r is less than 1. Here our r is equal to T3 divided by T2 or T2 divided by T1. Therefore let's say that r is equal to T3 divided by T2 is going to give us 81 divided by 90, which is equal to 9 over 10 is equal to 0.9. Okay, our a, we know that our a is equal to x, which is T1. Therefore a is equal to 100. Okay, So guys, let us continue here to prove that, to show that Sn is equal to 1000 into 1 minus 0,1 0,9 to the power n. Therefore Sn is equal to A, which is 100 into 1 minus R, which is 0,9 to the power n. Okay, then divide by 1 minus R, which is 0,9. Okay, therefore Sn is equal to 100 into 1 minus 0,9 to the power n, divide by, when we say 1 minus 0,9, we are going to be left with 0,1. Okay, therefore Sn is equal to 100. When we say 100 divided by 0,1, it's going to give us 1000. And then we are going to say 1 minus 0,9 to the power n. So we have proven this question, guys. Here is our Sn is equal to 1000 into 1 minus 0,9 to the power n. We are done with question 2.2. Let us now jump to question 2.3. Here, guys, is our question 2.3. Question 2.3 is the last question of our question 2 here. Question 2.3 is saying, hence or otherwise calculate the sum to infinity. The formula for sum into infinity, we know that it is saying that Sn is equal to A divided by 1 minus R. Therefore our S to infinity is equal to sum to infinity, so we should have said sum to infinity equal to A divided by 1 minus R. A, we know that our A is the first term, which is equal to 100 divided by 1 minus R. Our R is equal to 0,9. Therefore it's going to be equal to 100 divided by 0,1. Therefore sum to infinity is equal to 1000. So guys, we are done with this question, which is question 2 of this question paper.